Hi folks, I'm the inventor of the BioBlaster ozone machine, and today we're going to go over the very basics of just exactly how is ozone made. The first type of ozone that we're going to talk about is the most primitive kind, and it's the kind that was invented by a man named Nikola Tesla. Tesla is world famous, and he's also infamous. One of the things that you might be aware of that's pure Tesla technology is the lowly spark plug. You see folks, a spark plug is two pieces of metal, the one that goes through the center and then the one that's on the outside that threads into the engine. And in the middle of this is a thin piece of ceramic. The DC current from the battery of the automobile is taken to high voltage with a coil, and that high voltage is passed between the dielectric and the two pieces of electrified metal, in this case the ceramic and the post, and it generates a spark which will jump across the gap. And yes, a spark plug will make low levels of ozone. This is a primitive spark gap ozone machine. This is one of Nikola Tesla's first primitive prototypes for generating ozone. And what happens, and the way ozone is produced, there are two basic ways. The first one is called corona discharge. The second one is through UV light. In nature makes ozone both ways. Electricity in the form of lightning, high voltage DC current, passing through the air will create ozone, called a corona discharge version of ozone. The other is UV light shining on particles of water in the upper atmosphere at the right frequency will generate particles of ozone. And in fact, ozone is what makes our sky blue, folks. So in this machine we have an electrified media and a ground, and in the middle we have a dielectric medium, which is an insulator, something that doesn't allow electricity to penetrate. In this case we have air. So when we pass high voltage current, we're going to take alternating current in low voltage from our wall outlet, and we're going to pass it through a transformer which will convert it from low voltage to high voltage, and then we're going to take that and pass it from an electrified surface with a dielectric and a ground on the other side. In the middle we're going to generate a purple spark, and this purple spark will create ozone. So we'll go ahead and show you how that works. So folks, you can see the spark jumping across that gap. That spark, that high voltage DC current in the air, is what is creating the ozone gas. Now if we take a fan and put it on the other end and stick it in a box with a grate on either end, we will have a primitive ozone generator. This ozone generator, however, will not make massive amounts of ozone because there's a relatively small surface area of air that air has to pass across to generate the ozone, namely this tiny little spark gap in between the two. So I'm going to turn this off, and when we're passing that current between the air, as air from the fan blows across that gap, it will take oxygen from the ambient air, and the high voltage will take the O2, which is stably bonded, and add a second O. O2 plus O equals ozone. And this is another version from one of our competitors. This is the second way ozone can be generated. And in this case we have the transformer, which transforms regular wall current into high voltage DC current, and then it takes and it passes high voltage current in between a series of generator cells. This one has 7 cells, and in the middle there are small pieces of electrified stainless steel, and in the middle we have our dielectric medium. This time we're not using air, this one uses mica. Mica is an average to good dielectric media for generating ozone. Some of the drawbacks of using mica as a dielectric is it is possible to create a burn through. And if we put a fan behind this and we stick it inside a box with a grate on each end, we have another primitive ozone generator. This one is created by one of our competitors, and in fact when it's stuck inside this case, the air that blows from the fan past the transformer and makes it across these series of electrified stainless steel with the dielectric mediums in between will create ozone. And the third way, or the second way of generating ozone, is the other way that it's made in nature, using something called UV light. So I traded for this ozone machine. This is a very expensive, high dollar ozone machine. It cost over $1,000. And this machine will generate ozone gas as well. And like all ozone machines, folks, it's basically a fancy piece of bent, shiny metal. And I'll show you what's under the hood. So when you lift this hood off and expose the inside, you see that there are a series of special frequency light bulbs. And when these light bulbs are exposed to air, it'll create ozone gas. The ozone is created in low volume, not high volume, however. So in this machine you can see a computer fan at one end, then you have a series of ballasts which transform the current, and then you have the light bulbs, and at the other end we have the outlet. Now this machine is really silly because it uses two pieces of vent material, and both of these pieces of vent actually restrict the airflow from the fan. And it's at the air passing along the light bulbs that will generate the ozone effect. Now, people ask me, what's the difference between the corona discharge method and the UV method? Well, very simply, folks, UV light does not produce high enough levels of ozone in order to create shock treatments. If you really want to kill mold, mildew, viruses, or odors, you need to make massive amounts of ozone. And the only way to do that is with the corona discharge method. So, over the years we've experimented with our designs, and one of our first improvements to the design of ozone generators themselves, and I'll turn this one on and let you see how it works. Now, the UV light is dangerous to look at, so I will not be looking directly at the camera during this segment. So folks, you can see we have the corona discharge, high frequency ozone. We've got the UV light method. Both will make ozone. However, only the high voltage corona discharge method will make enough ozone to create high enough levels for shock therapy. With these light bulbs running, it's possible to stay in the room while the ozone is being generated, because it's just not making enough ozone to be effective. I'm going to turn this off, and then we're going to show you some various other types of ozone generating equipment. So we've talked about the basic air gap or spark gap ozone method. We've talked about mica being used as a dielectric. Here's another popular dielectric media. I don't know if you can see this. This is a thin piece of what's called borosilicate glass. It has sharp edges because it's broken over time. And on either side of the borosilicate glass is a piece of stainless steel that's glued down around the edge. And in the ozone machine this thing gets inserted into, high voltage current will be passed on one side and the ground on the other side, and in between the glass forms the dielectric media. This borosilicate glass is a popular thing in low dollar ozone equipment, but as you can see, it is not durable, it's relatively fragile. The benefit of glass over mica is the glass will never burn through. It requires much higher temperatures to create a burn through. Mica will burn through at relatively low temperatures. And then finally, over the years in testing our equipment, I've tested several different types of dielectric media. The one that I've settled upon that I like the best is very thick ceramic. So in our ozone machines we use ceramic paddles, and on one side the electricity passes across the electrified printed nickel. You can see all these very lines will create a lot of surface area, And all of this will get electrified during the process of generating ozone. So we have an increased amount of surface area on the cell. And on the back side we have the other piece of electrified silver. So again, the current is passed in high voltage on the other side, the ground on the other side, with the dielectric media in between. And our machines all feature a design that allows these paddles to be easily changed should they ever burn out or wear out or need to be cleaned. They're rated for over 3,500 hours. So for a regular homeowner, it'll last you virtually for the rest of your life. And for a contractor, you'll get thousands of hours of use without having to replace them. But again, this type of media is what we have selected to use in our machines. And originally, however, what we had decided upon, when I initially started building ozone machines, I took apart dozens and dozens of different manufacturers' machines, most of which I had already bought, my men had broken in years of service in mold remediation. And the first thing that I decided to do differently is I decided to turn the generator cell or stack into an actual tunnel. See, when you have all of the components inside a case like this, ozone is ambiently created inside of this box, and the ozone affects all of the connections inside the equipment. And ozone, being a heavy oxidizer, can easily cause corrosion to wear and decrease the lifetime of the machine. So we built ours with a double stack method, and we found a way to weld stainless steel to copper, which had been considered to be impossible using a hydrogen gas. This is one of our prototype generator cells. And if I turn it on, it will make massive amounts of ozone. And we took this basic double stack cell and built it into this heavy duty ozone tunnel. And by applying the air at one end and having the outlet grate at the other end, we're able to confine all of our ozone that's being generated directly inside our tunnel. And that's one of the first patents pending that I ever applied for, is for the ozone tunnel inside our machines. So I'll turn this off and I'll show you the problems with this design. Once the tunnel has been built, this is actually a tunnel that has been used, and I don't know if you can see all of the black carbon ghosting on the wires. This is literally blackened on the inside. These wires were white when we built this. And what happens is it makes for a design that is not easily repaired. And once the carbon ghosting gets to a certain buildup, no longer will it function to make ozone at high levels. So we had searched the globe high and low for a better dielectric media, a better way of making ozone cells, and that's when we selected the ceramic grade cells that are made with printed circuitry. So our new design still incorporates the use of the ozone tunnel itself. And I'll clear away some of these other cruddy models. This is our latest ozone tunnel design. It still has the super heavy, super thick walled, rugged ozone tunnel that separates the generation of ozone from the rest of the stuff inside our ozone box. And when we turn this machine on, it begins to make massive amounts of ozone. We're going to turn off the lights and let you see how this looks in all these various types of equipment. If you look inside the ozone tunnel, you'll see the purple glow indicating the ozone being made. Here's the old generator cell. You can see this less purple glow because there's far less surface area generating the ozone. If we put them all in here, we're making massive amounts of ozone, and that purple glow is what lets you know you're making ozone. So folks, we took this massively improved generator cell with the better ceramic grade dielectric, and we built it all into the most rugged cases on the market. rather than relying on a thin piece of sheet metal or a piece of vinyl fence post, we build our machines into the world's most durable toolboxes. We took our ozone tunnel and we built it in and connected it to the world's most powerful blower. And when our ozone is generated, it shoots it far out of the box, making mincemeat of mold, mildew, odors, and bacteria. So I encourage you, don't take my word for any of this. Buy one of our fine machines today and try it for yourself. You won't be disappointed.